The ice tables continue. Here we have the formation of gaseous hydrogen fluoride. So if you want to make HF, you better have some H and you better have some F in their elemental forms. And from that, we're going to make HF gas. And if we're balancing that, we'll have two HFs and one of each other thing. So there's our equilibrium reaction. And they tell us the KEQ is 115. That's probably going to be important later. And let's see what they have to tell us. In an experiment, 3 moles of each component was added to a 1.5 liter cylinder. Not a 1 liter cylinder, so red alert, we have to calculate concentrations here. They also use this kind of fuzzy phrase, each component, which I'm going to take to mean each of these species, including the HF. Could you argue it the other way? Absolutely. But I'm going to do it this way, and we'll get some practice. And if you want to run it the other way, be my guest. This does not have a standard meaning that I am aware of, so let's just take one and run with it. For each of these things, the concentration is going to be number of moles divided by volume, which is 3 divided by 1.5, which is 2. So we have 2 moles per liter of each of these things before the reaction starts. Then some stuff happens, and I'm going to assume that some hydrogen gets used up, and some fluorine gets used up, and some HF gets made. What do I put here? Just X? Good, not just X. Instead, 2X, right? Because our proportions are 1 to 1 to 2. And so our hydrogen amount will be 2 minus X. Fluorine will also be 2 minus X. And our HF will be 2 plus 2X. Okay. And generally, if we want to understand what these will do, we're going to write our equilibrium constant, or our reaction ratio, whatever you want to call it. So our product is HF, 2 plus 2x, and it's squared because of the coefficient, divided by hydrogen is 2 minus x. Oops, try to be a little legible. And can we agree that because it's 2 minus x twice, I can just write a square here? The square root's coming, you can feel it. Okay, 115. Quick thing before we go on. I assumed here that we're going to use up hydrogen and use up fluorine and make more HF. But I could be wrong about that. This system might decide it has too much HF and run in reverse. If that happens, this setup will still be okay, but what will happen is my X will come out negative. And that negative number will be telling me, no, you're wrong about the direction here. These should actually be pluses because minus a negative number is a plus. And this will come out minus, saying we're actually going to draw down some HF and convert it back into hydrogen and fluorine. So it'll be interesting to see if I guessed right about that. I guessed that way because the K is enormous. So I have a feeling I'm right, but you might see me get slapped down shortly. Let's find out. So we have that thing with the double squares again, so we'll cancel that in the usual way by square rooting both sides. That square gets stripped off, so does that. And now we have 2 plus 2x over 2 minus x equals, and the square root of 115 is 10.724. Okay, we want the 2 minus x gone, so multiply both sides by 2 minus x. Those cancel. And we have 2 plus 2x equals, this 10.724 distributes through the brackets, so we're going to get 21.448 minus 10.724x, gross, Now, we have to segregate this so we have our x's on one side, I'd prefer the left, and our numbers on one side, I'd prefer the right. So this 2 has to go. It's on the wrong side. I'm going to go -2 and -2. Also, this 10.724x is on the wrong side, so I'm going to cancel that. I'm going to say plus 10.724x, and the same on the other side. 2 minus 2 cancels. 10.724x and its opposite cancel. So when the dust settles from all that, we get 2 plus 10 is 12.724x equals, and 21 take away 2 is 19.448. Sorry, that's a 9. Divide by 12.724, and hopefully that will do it. 1.528. X is 1.528 moles per liter. Now, that isn't the answer for any of these things. That is the change amount for hydrogen and for fluorine. So to finish this, we get to take 1.528 and plug it in there, there, and there. 2 minus 1.528 is 0.472. Fluorine, exact same thing. And for HF, let's see, 1.528 doubled is 3.056. Add 2 and we get 5.056, if I did that right. Are we okay for 3 significant digits? I think 3. Yeah, I don't think we used any numbers that were worse than 3. So that means 0.472 is okay, 0.472 is okay, and this is not okay. This has 4 sig digs. That we should trim to 5.06 moles per liter. If you use more precision than me and you get slightly better numbers, then again, you did a more careful job than I did, and you should trust your answers more. And kudos to you for doing that. But I hope the procedure makes sense. Hope you're feeling okay about this, and we will see you in the next